So my name is Eben Kirksey, and I want to welcome everyone to the third Multispecies Salon we're doing this fall at Princeton. And we've got a wonderful team here to talk today about chemical species. So chemical species change quickly. Formaldehyde, which is one of the chemicals we're talking about today, only will remain as a species for around 6 hours in the sun before shifting shape. In part today, we're discussing an essay by Nicholas Shapiro here on my right, Attuning to the Chemosphere, which was recently published in the flagship journal of our discipline, Cultural Anthropology. And we also have a piece by Bourg, who has written a recent article about sealing shales versus brittle shales. So we've got an artist here today who's manufactured some awesome objects that we're all drinking from, or some of us are drinking from. These were manufactured with clay from the Marcellus Shale, and as part of this art exhibition that opens tonight in Ehrenberg Hall in the Anthropology Department. So there's a number of works, including one by Ali Frazier, who's on the line from upstate New York. And Ali offers us images and artifacts of the Kodak plant upstate in New York, illustrating haunting entanglements connecting mid-20th century visions of modern Kodachrome utopia with blasted landscapes and cancerous tumors, looking at the people who worked in these plants, who took some amazing mid-20th century images, and then also some of the material substances and toxins involved. Another Ali, where's the other Ali, is here on my right, Alison Kenner from Drexel, who's working on a book about asthma and is going to be a provocateur and discussant today to keep the conversation going. So why are we talking about chemical species, or why are we talking about chemistry in the Multispecies Salon? I did some research in collaboration with the reference librarians here yesterday, and they pointed me to Wikipedia. So here's what chemical species are according to the definitive resource of our time. Chemical species are atoms, molecules, molecular fragments, ions, etc., that are subjected to chemical process or measurement. So basically, they're chemically identical molecular entities. And if species in a biological sense only emerge over long periods of evolutionary time, the dynamics of chemistry are taking place at a much quicker time scale. So for example, if you take table salt and put it into water, you don't really have an ACl anymore. That's basically changed into two different species. So you have sodium and chloride ions that are working around in this water solution. So let's see, in this case, the species present in the solution are the ions. In other cases where the molecules don't dissolve in water, if it was something other than table salt that's readily soluble, we would have a molecular species in solution rather than ionic species. So the molecule salt is a species, and then we have two ions that are also species. We're not going to actually talk about species that much today. I mean, in part, this is just sort of a framing, bringing this long-standing intellectual project, the Multispecies Salon, into contact with the chemical. And I might just say that if y'all are interested in how the species concept works in the realms of biology, I've got a freshly published piece that wrangles with the contention that species are human constructs. I'm basically interested in how other kinds of critters also engage in the work of recognition, differentiation, and classification. So this is a freshly published piece if folks are interested. But again, multi-species dynamics are happening much faster in the realm of chemistry. These things are happening as fast as salt and water or formaldehyde in the sun shifting shape in 6 hours. So I'd like to turn first to Nick's paper, and maybe for folks who aren't part of our disciplinary tradition in the humanities or social sciences, unravel and unpack some of these key words in the piece. So one of these is the word sublime. So it comes from French, and in some of the earlier instantiations, it referred to a quality in nature or art which inspires awe, reverence, or other high emotion. That's a 1690 definition. Later on, it came to mean something of flight, soaring, ascending. Of language and style or literary works, it was a way of expressing noble ideas in a grand and elevated manner. So in your piece, you talk about Kant's definition of the sublime, a European philosopher. and you go point by point to talk about how your definition of the chemical sublime is different from Kant. So maybe I'll open it up to you with that, just talking about the sublime and in context of that history.
Sure. Thanks for having us. I don't know the background for everyone here, so should I give a little primer on the philosophy of Kant, or that sounds like a bad way to do that? Or are we mostly natural scientists?
Super interdisciplinary. We've got people in the English department, ecology, chemistry, so yeah.
So in the paper I'm dealing with Immanuel Kant's idea of the sublime, not necessarily because it's the only way that we understand and interact with this concept, but because he's a central figure in philosophy. He's important for ethics, aesthetics, political philosophy, epistemology, and he was born in 1724 in what is now Russia, but was then East Prussia, and his idea of the sublime is intrinsic to like the project of the Enlightenment, and what I try and do in the paper is show that there's actually other ways of experiencing a feeling of awe and grandeur than the ways that Immanuel Kant outlines. And so sublime in general, as Eben has indicated, is like a feeling of reverence. It's a feeling of smallness. And Kant says that this feeling of smallness, whether it's a physical threat by the environment, earthquakes were a fascination of his. The Great Lisbon earthquake was part of the inspiration for his idea of the sublime, where he felt at once a trembling, a reverence for this force that was huge and powerful. At the same time as it made him emboldened, and he felt like the power of the mind surpassed the power of matter, and the supersensible ability of human consciousness and reason was triumphant over a material threat. So that's where the pleasure came from. There's a threat, and then it's sublimated into a pleasure. And so this is often how we mark time. So today, oftentimes you feel like nothing's happening unless there's a gigantic event, unless there's something that gives reckoning. So 9/11 signifies a break in time. Certain kinds of school shootings change the way that we orient ourselves to the contemporary moment. We step outside of time, and they're openings for political interventions. Oftentimes, that specific kind of the sublime reinforces what is already happening in society, whereas there are other kinds of sublime that I was finding in my fieldwork. So the kind of sublime, we're going to start abstract, and then we're going to get grounded in the material. So the kind of the practices that I was seeing was that people were expanding their idea of sensation, of what can be sensed. And so I think a lot of times we attenuate what we think our bodies are capable of sensing. So it's not just the overt violence of an earthquake. It's not just the mathematical, overwhelming idea of infinity, but it's oftentimes small, incremental encounters that take place over a great period of time. So not just a spectacular moment grounded in a specific time, a specific place, such as the explosion of a nuclear bomb, but also possible encounters that we're having all the time every day. So this table that I'm gesticulating at is held together with formaldehyde. The wall paneling likely also held together with formaldehyde. The engineered woods that give form to this room. The carpet backing is here to the ground with formaldehyde. And places with acute exposure, people are using their bodies to understand these encounters with vast infrastructure. So this is a small room that's an instantiation of a global petrochemical industrial manufacturing process. So it's a small encounter, molecules inhaled slowly at a normal rate, encountering our bodies, and also orienting us towards the infrastructure that gives structure to our lives and enables our standard of living. And so people in these acute spaces of exposure, like trailers, were using their bodies as measuring instruments. And they're using slight, very small aberrations in their biofunctioning to do this. So we think of the chemical senses, physiology that tells us the chemical senses. We sense chemicals with our nose and our tongue, taste and smell. But really can tell us a lot about very, very large things. So giving attention to these small things is moving people in the way that the sublime often move people. So, after the detonation of the first nuclear weapon in the American Southwest, the scientists were either moved to really move to excitement for their godlike power, or they were moved to a desire for disarmament. So the sublime moves people, and it creates politics. And so I'm also finding more subtle, ongoing, and corrosive forms of the sublime happening all across America. And so these are political openings, and these are ways that people are operationalizing the tools that they have, which is their bodies, to understand large-scale, massive infrastructures that are intrinsic to our way of life, and they're creating distributed attempts at changing those systems. So that's really what the sublime, the chemical sublime, to me is about. Is an alternative way of aggregating the small and corrosive violences that sort of constitute contemporary society. And so, and
I just wanted to read one of my favorite sort of encapsulations of this notion. You talked about the mind-numbing nature of some of these toxic exposures as being part of the chemical sublime. So you say the chemical sublime elevates minor enfeebling encounters into events that stir ethical consideration and potential intervention. The chemical sublime is both an experience and practice that emerges out of late industrial material ecologies, one that inverts dominant conceptions of the sublime that hang heavy with Enlightenment era baggage. And I think with that, I might turn it over to Ali and invite her to start provoking and interrogating our interlocutors today. And doing some of my work.
And so I mentioned Nick knows this, Evan now knows this, but I teach, I've taught this particular essay in my classes at Drexel a few times now. And we just read this piece last week in my Health Geographies grad seminar, as the theme of the week was exposures. And then last night we read ethnography called Cancer in the Community. I don't know if you're familiar with it. It's an older piece. It's from 1993, written by who is an applied medical anthropologist, and it's about cancer in river wards, which is this neighborhood in Philadelphia that Nick and I both have ties to. And so in reading Nick's piece, one of the things that I love so much about this piece is it's very visceral, and so Nick's descriptions of people's sense of exposure and sense of space there's an immediacy to it that's incredibly powerful, not just in the kind of experiences that his interlocutors have, but also as a reader. And I've been thinking a lot in my own work about the relationship between these exposures and their affects and how that accumulates into disease. So I'm a medical anthropologist and I'm interested in chronic disease and environmental health conditions. And so thinking about the way that Nick is using these exposures and these sensations as a form of evidence in the piece, I'm really struck by the way that people are using these immediate exposures and sensations and their subclinical symptoms as a way to, as a form of evidence of what's happening in the environment in a way that's risky and producing harm is very different from cancer. There's similarities between like cancer in the community and what you're describing about the chemosphere. So this idea that, you know, the exposure is happening over time at a slow rate that's accumulating, and people are becoming sensitized to it. In a community in a fence line community, people often know that they're being exposed to stuff through their bodies, through smells, but sometimes not. It's just the conditions of the material environment, it's their health conditions, and it's also the talk that happens between people in that space, in that community. And they are making connections between, you know, these global processes and relationships of production and the infrastructure. I'm wondering how your case is different, and I'm wondering how the distributed nature of formaldehyde exposure, the people that you talked to, one of the things that's amazing about Nick's project is that it was multi-sited. He was talking to people all over the country. And so it's very different from how we understand cancer clusters in a fence line community. And oftentimes in those cases, the power, the political movement that affect is producing is really anchored in that particular space. So how does the fact that this is not happening in one particular like community or space and place and time, how is that different from what maybe happens in fence line communities in a way that is both blocking political movement or in a way that's enabling it? Because sometimes like the political movements that happen in communities, fence line communities where there's these industrial facilities, people are being exposed, there's high, you know, disease rates. Disease registries, for example, are a form of evidence that show the connection, some connection between industrial exposures, chemical exposures, and disease. And yet that doesn't always translate into some kind of political, ethical movement that can address disease in the community.
Yeah.
I have, there's so many, it's such a rich piece, and I have so many threads to pick up. But
I'll try and
yeah.
move through it quickly. So one of the main differences, I mean, that's how environmental justice normally works. You have a community, there's a fence line, community is sort of largely pre-existing, maybe there's some class or racial fault lines in that community. They either come together or they don't. Scientists are involved or they're not. That's the usual story. So it's a little different. Also, with the industrial emissions, the idea is usually it's an aberrational. It's like the factory is doing something wrong. Either they're emitting more than they're supposed to, or there's a leak, or they shouldn't be that close, something like that. So another difference is in what I study, the emission source is not out there. It's not an external emission source wafting through your windows, coming in through your pipes. It is the structure that creates shelter for you. So when exposure itself is emanating from shelter, there is a reckoning on the very idea of protection, on what is common and what it means to be working. You know, so nothing has to go wrong for you to be exposed to formaldehyde. That's life. That's late industrial life working as it's supposed to. So I think those are part of the issues. Also, people are experiencing these things by themselves, and you know they manifest differently. So they often manifest in depression and suicidal ideation and things like that, where there's no community to work with. And different chemicals have different affordances. So formaldehyde is an allergen, it's an allergen, an irritant, a neurotoxin, and a known human carcinogen. So since I've been studying it, it's been classified as a known human carcinogen in the United States. I've had multiple collaborators in the project that feel like they have died from because of formaldehyde exposure. So these affects are intimations of longer scale latency issues that are really significant. So, I'm working with a community in South Georgia right now that is seizing upon formaldehyde as an indicator of maybe why their cancer cluster exists, and they actually can't go out and monitor because they're too sick from their homes, the formaldehyde levels in their homes that are part of their engineered wood that holds together the home. So sometimes they overlap in that case. But I think there's a question here.
We love that question. For sure. It strikes me that one huge difference is that in order for something to have this sublime effect, it has to be identifiable. And so in your case, you know the species. And it's just this in biology. It's something you just have to know which it is. But it's more fundamental than that. You can name it. And if you could name a class, if you really could name a class of cancer-causing chemicals, then it becomes easy. If it's pollutants, that becomes much harder, unless they are distinctly visible. And there are examples of that, such as particulate carbon emitted by diesel engines run at low efficiency that are simply eliminated from any regulation for political reasons.
And I might use that as an opportunity to bring Jennie and Ian into the conversation. And in part, I think what unifies these two projects is the shared enormity of what we're talking about. So the formaldehyde that's everywhere is connected to all these other ubiquitous chemicals. So I was wondering, Jennie, if you could just start out by telling us about these objects and help make familiar containers that we have all around us strange.
So the cups that are in front of you are made from clay that I made from Marcellus Shale.
What is Marcellus Shale?
Marcellus Shale is a type of shale, the type of shale that they're using now, all the gas extraction that's going on, fracking, is occurring in Marcellus Shale. So it's a type of shale that they're essentially, with this process, has been very effective in being able to harvest a lot of natural gas. And there have been questions around the process that they use for extracting this gas, because they're pushing these fluids into the shale, which is very brittle, use a current. There's questions about whether these fluids can find their way into water aquifers. And in western mid-Pennsylvania, western Pennsylvania, upstate New York, a lot of places around the country where this is happening, there's this fight between the need for jobs and the need for regulations and safe procedures and things like that, so that we know that the benefits of this natural resource are coming to us without, almost risks that people see as being almost like biblical in the possible scope. And I found out that I'm not really a ceramicist, I'm a sculptor. I learned that shale makes exceptional ceramic clay materials. And when I learned that, I immediately thought I want to make cups out of Marcellus Shale. People understand, have a sense of the idea that, it's problematic. There's an issue with water and safety in these things. But even in Philadelphia, where I'm from, most people feel like, that's out there. It's not really my issue. Having a cup like this in your hand, you have to start asking questions like, is it really safe to drink this stuff? Like, who's the person who made this? How do I trust them? What's in this object? And those are the types of questions that it would be good for us to be asking really of anything that's made. During the process of making this, because I had concerns myself, digging the clay, working with it with my hands, I didn't know, what safe procedures would be. I worked with the geologists at Temple University. I teach in the art programs there. Geologists helped me test the materials. They told me different elements that were in it, so that when I was working with the raw clay, some samples had too much lead, and I thought, okay, it would be better to wear gloves for this. Some samples were fine. They also told me things that I should be concerned about after. Like we did tests essentially, and I said that I wanted to be sure that these would be food safe. So they told me what I should ask the FDA lab to test for, because they knew they were able to see what was in here. There are between 6 to 9 items, depending on the clay sample. And what I learned from the FDA lab is that they only regulate for lead and for cadmium, while there are numerous other elements in soils that we have good reason to have concern about. And what I learned is actually, so these cups that you're drinking out were, at first you might be concerned about drinking out. These are actually safer than almost anything you've ever had drank out because they're tested more, and I know that they're fine. You just wanted me to talk a little bit about the cups, right?
Yeah, and I think back to Henry's question, I think knowing what species of chemical to pay attention to is part of the question. The way that the apparatus of regulation is working right now is that it's only paying attention to these two very specific things. And there's this broader set of things, and maybe even an unknown, like in this moment when industrial chemistry has brought all sorts of chemicals into contact with our bodies. And part of what I take away from your project is the routine hazards that I expose myself to by drinking out of a coffee cup or drinking out of any other sort of thing, and how these everyday objects suddenly became strange for people, and I realized that no one is really paying attention.
Yeah, well, there's a kind of infrastructure that's there that's meant to allow us to have trust. But then the question is, is that trust? Should we still be questioning? Where can we trust and where should we?
Just a question, what else did the geologists ask for a test for?
I can send you a list. It's actually, I have a blog, marcellusclay.blogspot.com, and you can download the PDFs of all the testing, both the Temple lab and the FDA lab.
Maybe Ian, I might invite you to respond. So Ian is an expert in shale, so more than anyone else probably in the world, he can answer your question about what is the Marcellus Shale, and just also inviting you to.
Well, I'd be interested in linking formaldehyde shale. We don't know here in the environmental engineering department here. And one thing that I enjoyed from reading the article was, one thing that it made me think of was that this concern in environmental engineering that a lot of the contaminants that people used to be more concerned about were ones that had acute toxicity effects. So I don't know, breathe some carbon monoxide. If I breathe too much, it kills me. But it's easy to, or if I drink some, I don't know, like cyanide, that's going to kill me. And that's something that we've kind of evolved to be able to wrap our minds around. It's, don't get too close to the sacred food tiger or something.
Mm-hmm.
And we also have a language for talking about them. Whereas the formaldehyde issue, the people in the article who were being exposed, they were getting these headaches and double vision and stuff like that, but they didn't know what was going to do. So it's not so much of an acute effect where you can really easily see the cause and effect. It's more like the progressive continual exposure of them to these chemicals is making them increasingly sick without them being able to easily see what the cause was. And that's kind of, that links with cancer, because in cancer there's also an issue, I do some work in the region near Fukushima that's contaminated. And one issue that people have is, okay, they know that there's some general radioactivity in the region. They don't know, well, for one thing, we don't have the language to think about the danger from exposure to it, because it's like, well, if I get a certain radiation dose this year, that might increase my chance of getting cancer 30 years from now. So that's not really like a very neat cause and effect. And then talking to the scientists over there, actually, what they were saying was that the people who were trying to live in the contaminated region, not too contaminated, but they're still not to live, the main demand that they had was for the scientists to tell them, how can we adapt our behavior to limit exposure? So if I tell my kids go play near the river, or if I tell my kids stay inside, you're not allowed to play outside, how is that going to change their chance of getting cancer later in life? And not having the information is kind of similar to this issue with formaldehyde affecting people who don't know what's affecting them. So we really don't have a way of thinking or talking about these pollutants that have a non-acute, but kind of gradual effect on our bodies. And that links with the shale mugs, because, I mean, if this shale mug were obviously toxic, I would drink from it, I would probably be feeling pretty ill, and then it would be easy to draw the cause and effect. But, if this is a shale mug that comes from Marcellus Shale, and there's some kind of thing that might increase my chance of getting cancer 30 years from now, there's no way for me to know that, So the fact that we see more and more issues with these chemicals these days, hazardous chemicals that have kind of like this non-acute effect, that also tends to make people more suspicious, because they're like, well, this fracking, is that going to increase our health risks in the future? Obviously, nobody's like immediately dying from fracking, but people want to know if it's going to affect their long-term exposure to hazardous contaminants.
So some of that conceptual work has actually been done by Rob Nixon, who's just been hired here at Princeton, who's coined this concept of flow violence, to think about the ways that certain chemicals aren't just acute in the way that cyanide would be, but sort of the long accumulation of toxic exposures has impacts on our bodies and on the multi-species communities that we live in. But I also wanted to take what you were just saying, even as an opportunity to bounce it back to Ali and Nick. I think one of the really neat things about this article is that it shows not just how these mechanical sensors work for formaldehyde in particular, but how the human body might be attuned and sort of work in conjunction with these technical apparatuses that we take off the shelf. So maybe I'd just like to invite the two of you to have sort of a dialogue about that, about the ways that both your body was brought into this research project and how the bodies of these people you interviewed were affected and moved by these chemical ecologies.
Can I also briefly touch on Henry and other points? So exactly, you're reading on the chemical exposures that people didn't actually speciate is totally right. So sometimes when people were exposed, they were orienting to a source, but not necessarily actually speciating. So people knew more often where it was coming from through these experiments with the body. So they'd leave home, they'd leave home for a few days, they'd feel better, they'd come back, they'd open a window, they'd feel slightly better, and through these experiments they would come to know a source, and then they would test for the things that they could get tests for. So maybe it's sewer gas, there's someone responsible for that. Come test that, it's not sewer gas. So they often knew what it was not, as opposed to what it was. So it's like speciation of negative.
And then, if I can interject, I feel like, so there's some studies related to radioactive contamination that show that the stress of not knowing what's affecting you or what might be affecting you is also really unhealthy for you.
Yeah.
So they're not just being chemically affected, but also mentally by not knowing what's making it.
Yeah, toxic anxiety is massive. And then it's also really interesting hearing about the desires of the communities near Fukushima, where their orientation, their intervention that they want to know, they want information for behavior change. So they want to know how can they limit their individual exposure, not how can we limit our individual exposure, but also maintain a global system of safe nuclear reactors. And so I think that's also maybe a difference between like the NIMBY model, like not in my backyard refinery model, and also distributed system where the only way they can really mitigate their own exposure is by changing the whole system. And so this behavior change is a big part of environmental sensing. So consumer sensing is really a growing phenomenon, part of smart cities, part of the wearable sensor movement and zeitgeist that Silicon Valley is forcing sensors upon new clientele and building new markets. And so a lot of these sensors are focused on how do I navigate the city better so that I don't have to get exposed, as opposed to we know what the problems are. Let's deal with the large-scale infrastructure. So it's interesting how people's responses to different ecological disasters are configured and their orientations changing in those ways. But in terms of I guess sensing practices, I think it's a growing part of the science today's literature about how scientists' bodies are important registers of scientific information and pedagogical tools, from Natasha Meyer's work on crystallography and how modeling proteins often, and making sense of modeling proteins, involves people actually reconfiguring their own bodies, sort of the choreography of that. Joe Masco's work that I cite in his paper about the bittersweet pleasures of feeling blown back by a nuclear detonation was part of a successful experiment, but also had other political reckoning. So the scientists' bodies are always part of it, and also, I guess, part of the juxtapositional logic of the paper is to show that scientists are doing this with using their bodies as extensions of their instrumentation, and sort of indwelling their instrumentation into their own body and somatic practices. And these practices that are done by authoritative bodies are also being done by non-authoritative bodies. So people are using these same methods across a wide variety of political, economic, and spectrum and sort of political power.
So I'm wondering, because this idea of how do you make, the non-authoritative body. So scientists have this authority that they use, but how do you make the data, the experiences, the somatic attention that people experience in their homes? How do you accumulate that sensorial data and make it accumulate into a form of authoritative knowledge? I'm really interested in how your work moves in that way. Because I see, in the case of formaldehyde, I see it as a layering of, both this kind of chronic exposure and increased sensitization of the body, but you also have the immediate effects where, the woman walks into the room and she's immediately affected by the presence of formaldehyde. And so there's these layering of affect there that, how does that also come into play as we're thinking about producing knowledge around environmental exposure?
Yeah, so this is part of the sort of mainstream anthropological work of the project. I also am a fellow at something called Public Lab, the Public Laboratory for Open Technology and Science, which is a grassroots environmental monitoring nonprofit that builds open source environmental monitoring tools. So this highly theoretical paper, also empirical paper, launched sort of a ship in my research that was how do I make authoritative these really important accounts of the environment? How do I make recognizable the things that we're able to sense, but we're told that we're not able to sense? And so I've been working with an epidemiologist at the University of Michigan for 2 years now, trying to figure out a way for these affective encounters to be registered upon epidemiological registers. So science tells us that people are better at assessing their own health than doctors assessing health. So they're even on the terms of what anthropologists would assume would be sort of disqualified knowledge on the part of science. Science is already pointing to the extreme precision of people to understand their own health and changes in their own health. So we're trying to sort of operationalize affects in order to create epidemiological data and create, while creating this data, we're working on an online platform that actually bring people together so they're not just getting data extracted for some sort of better science and then maybe a policy intervention in 3 decades, but also for them to exchange sort of do peer education and connect, because the isolating effects of being in rural America by yourself in a mass-produced home by Gulf Stream homes, but there's 10,000 of those homes all over the country. You can unite across lines of infrastructure, across manufacturer. So that's part of the work that we're doing. We've built this open monitoring kit, this formaldehyde detection kit that has a nice low threshold for detection. 10 parts per billion, it costs $7 per test. And we were just in the Department of Health labs in Rhode Island testing it. And interestingly for this talk, the name of this talk is Chemical Species, we're having a really hard time speciating. So acetone and formic acid and other things that sort of react similarly to formaldehyde are also being picked up. So we're getting higher readings on that than we'd like. But so it's interesting that chemical species exist only in the encounter with the analytic chemistry. And in our case, it doesn't necessarily.
So circling back to this question about human bodies as sort of things that are impacted and affected by these chemicals. Like as a reader, I must admit I had some sort of skepticism, similar to what Ian was bringing up in the Fukushima context of, like is someone like Nancy just like so worried about toxic exposure that she's sort of psyching herself up. But then with this encounter where she's having spasms on the floor and then Bowser the dog shows up, for me that was the moment in the paper where my thinking about Nancy shifted a little bit and and I guess maybe it's because I'm like, an animal studies, multi-species, ethnography kind of guy. But so for me that was a moment, I don't think Bowser necessarily was, seeing Nancy convulsing and just going into some kind of yeah. And it seems like Bowser had a lot of convulsions before and after Nancy was there. So maybe could you talk more about Nancy's body as a chemosensory apparatus, or like what do we make of that? Like in your prose, I detect both sort of a gentle, careful characterization of her lived experience, and also a little bit of ethnographic distance. So I'd love to just hear more about her and these exposed bodies.
Yeah, I think most people's inroads into bodies as like human Geiger counters are through chemical sensitivity. That's been sort of a widely studied thing. There's been a number of books on it. And it's also highly controversial. So I don't necessarily, so my work, I don't want to exclude the idea that humans are Geiger counters for chemical exposure. I don't want to relegate it just to chemically sensitive people. It's and that's what a lot of people read my work as doing. It's like, okay, so you have some wackos that have aluminum tinfoil hats, and they think they can sense chemicals. What about the rest of it? That's not what I'm saying. So people seize Nancy in this article because she's the most spectacular figure of a body speaking to otherwise invisible chemicals. And I do think that the moment of dual fit and dual seizures is an important one. And I was talking to Ian about this briefly beforehand, but I think it's important to think of humans as sentinels for non-human problems, as well as what's most commonly done is animals are sentinels for human health. How do we utilize the increased vulnerability of certain species for us to get a better understanding of what toxins we're going to have? And so I think that these human exposures, I'm sort of hijacking your question a little bit, but I think these human exposures are part of being a sentinel for large-scale climatic changes. So formaldehyde comes from the shale that we are drinking from. So formaldehyde is a methane derivative. You oxidize methane, and you oxidize methanol, and that's how industrial produced formaldehyde comes into our being. So we don't have a chemically engineered materials that hold together our world without a world that's thirsty for hydrocarbons and thirsty for methane. So there is a common industrial practice where, but across all of the things that we're talking about. So methane is more potent greenhouse gas than CO2, although be it in the shorter term, you can probably speak to this more than I can, but it's also routinely released and vented and leaked during the extraction process. So clean natural gas is not without its climate change, and it's also part of, so that's how you can read Nancy, and you can read Harry and all the people that I write about, including my own body, as sentinels for larger scale, non-human sort of climatic change as a result of this commodity pipeline.
You know, another really good example, I can't help but think of the case of allergies. As an increasing rates of allergies, especially this year in a year of, higher pollen counts in the way that people connect that to climatic changes, but also mold and the way that people are sensitized to mold. So it's not, so it goes beyond, and that, the relationship between breathing disorders and allergens, I mean, that's, something that goes a long, long ways back as a form of exposure that tells us something about environment and environmental changes.
I might use that Ali as the opportunity to bring in the other Ali who's remotely joining us now. So I think our discussion today is situated within this broader trajectory in anthropology and ethnography, a sort of chemical turn, if you will. So Ali, I was wondering, it looks like your microphone's muted. If it's on, I was wondering if you could just maybe tell us a little bit more about your work in upstate New York, and tell us about the artifacts that you've given to the exhibit that's opening tonight.
Yeah, well, I'm in the process of doing research for a sort of social history of chemical photography in the 20th century with an attention to how it's endured and transformed into the 21st century. And I'm working in Rochester, New York, where Eastman Kodak was based since the 1880s. So my research involves oral histories with workers, as well as work with journalists who are involved in assessing the scale of contamination around Kodak's photochemical factories. So the pieces that were included in this installation, sort of at the center of it is a developing tank that contains 3 rolls of exposed film soaking in water from the Genesee River. Kodak's factory is located right on the river, and for the first 70 years of production, all of their waste flowed right into it. So there's a joke here in Rochester that at one point in time you could dip your film in the river and it would come out developed. So that's one of the puns that I'm sort of, photographic puns that I'm sort of working on here as part of your project. So yeah, the film is soaking in that water now. We'll see if anything comes out of it. I'm sure something weird is bound to have happened to the emulsion because I've carted this thing around and mailed it, quite a long distance. So something's bound to have happened in there. There's an image, distorted image, of sort of the fence line of Kodak Park. So I like including that because it's both sort of a depiction of the juxtaposition of the industrial and residential neighborhoods and sort of the warped effects of light in the image sort of attend to the physical decay of photographic materials over time. Yeah, and then I've also included some slides, which are mostly sourced here in Rochester at estate sales and Craigslist. Kodachrome and Ektachrome slides from the 20th century. Some of these were produced by Kodak workers. To get a juxtaposition with sort of the fantasies of the American good life that were both captured on Kodak film and enabled here in Rochester out of the photochemical economies.
And when you gave the talk, so part of what this conversation today is continuing an event that Nick hosted in Philadelphia last month called More Than Human Sensoria. And in that talk, Ali, you had this moment where you were characterizing these people's houses and how they were recounting, like factory workers at Kodak, they were recounting their illnesses and patting the walls saying, Kodak built this house, Kodak sent my kids to college. Could you talk a little bit more about that, the sort of prompt modernity contained in those mid-20th century images and how some of the unforeseen chemical species involved in that production process have had lasting impacts on their bodies?
Okay, well, your voice is a little fuzzy, so I'm going to answer what I think you said. But yeah, I mean, I guess like the way that I'm thinking of Kodak now is both as a family and as a political unit in Rochester. So people always talk about the Kodak family. They talk about the company founder, George Eastman, as George, sort of a friendly, wacko, rich uncle of the family. And I'm thinking about family as a complex bundle of promises and betrayals that is a warm and fuzzy thing, but also a site of trauma, a site of small everyday disasters, as much as it's also sort of a refuge from the harsh, cruel world of the market. And I'm thinking about photochemistry as being sort of the material substratum for the Kodak family. And I guess family was a way that it was sort of the corporate ideology. So there were these, for example, like Kodak circulated a newspaper to all of its employees that listed weddings and births and retirements and things like that. It promoted this sort of, you could bring your families along to events and parties and things like that. But I guess I'm thinking of family as a way of getting around false consciousness, which was something that came up when I gave this paper in Philadelphia last month, because Kodakers' relations to toxicity is manifold. There's both an acknowledgement of the fact that they were dealing with toxic substances and that they were emitting toxic substances into the community, but also an awareness that that community itself was created by film. So I'm thinking about, I guess, toxicity not just as something that is poisonous, but that is also generative of forms of life.
So maybe I'll bring it back to the room and open up this enormous paralyzing fact that we're sort of grappling with today. So the last lines of Nick's article talk about basically how decamping from these spaces where these toxic emissions are is simply not possible on a societal level. Telling us that these tables we're resting our papers on, the walls that we're surrounded by right now, that the things that we're drinking with contain these ubiquitous toxins. So what do we do with this story? And in my mind, the things we're talking about are so big that they're parallels. You know, I think part of what you're trying to point at in these final lines of the piece are just the enormous political project that it would be if you were to create a finely tuned regulatory apparatus to deal with this problem. So maybe I'll just try to open up the enormity of what we're talking about here, you know, and try to get out of that paralytic space, or maybe, yeah, maybe we must dwell in that paralytic space for longer. I mean, do you have any thoughts, Mike?
I'm actually really curious to hear what Nina said. I guess you're probably you're in the conversation with colleagues in industry and regulators maybe more than.
Well, not, but I looked up the EPA's regulations for indoor air quality. It turns out humans in the U.S. spend about 50% of their time outdoors and 94% indoors. Most of it in their houses, and then small percentage in vehicles. And on the EPA website, they just say, well, we don't regulate air quality. So all of our regulation of air quality is for outdoor air, where we spend 6% of our time. And none of it is for indoor air, which is 94% of our time. And then the next sentence is something like, if you have concerns about indoor air, for example, mold, formaldehyde, and radon, those are the three examples, you know, here's some additional information, how you can try to deal with it. But they don't, it doesn't seem like, so formaldehyde is regulated as a hazardous air pollutant, but only if you're emitting it into the air. Not if you're selling somebody something that contains it, and then it's seeping into the house.
There are industrial standards for it in some processed materials.
I think there are now in the U.S., and there are also in Europe, stricter, I think. And it's also listed as a hazardous pollutant, even construction material in Canada, I think now. I don't know how stringent these are.
The Green Building Council has made a lot of inroads talking about it, but construction materials like that. I actually think, like, management actually having to think about the house and engineered floors are the way it's relatively integrated there. But anyway, the management addresses come out, and I read the issues.
There are various non-mandatory regulations for particular kinds of certifications in various environmental.
And for the, sorry.
I was just going to say, I think it's a response really to, consumer awareness that this is a hazard.
I just wanted to, so for the shale, it turns out that the Clean Water Act prevents you from dumping anything into the river, except it specifically exempts oil and natural gas. So they can do it. Apparently, when they wrote the Clean Water Act, they just added a line, which at the time might have made sense because they didn't have fracking, they hadn't had to produce gigantic quantities of water, even very large quantities. But they can just send their wastewater from the municipal water treatment plant. Even though it might have hazardous content in it, apparently it's not treated as hazardous. Regulation always takes 20, 30 years to catch up with that.
I've actually been through this conversation. I hadn't really thought about in this area. A lot of people have wells. So what's coming with, what's coming into your house and before you drink and you bathe with, from the actual soil up until you actually try to sell your house. There'll be actually, there's like arsenic is one of the actual there's a regulation about that certainly, acceptable levels of arsenic you can remediate for that. I think they're on a daily basis looking for that. The focus certainly of fracking has been, what are all the toxins that the water being injected in, and who is being injected into, getting into the groundwater, but looking at
Oh, did you want to jump in? Just one of the commonest additives to make drinking water safe is chlorine. One of the effects that chlorine has is to narcotize your nasal surfaces. One of the effects that has is to decrease your ability to detect anything else. So that I've found that when I'm very, very strict filtering water, or in a cup and let it stay on overnight and tip off the bubbles and the like. If I'm really religious about doing this, or having well water with its arsenic, etc., and then my ability to detect all kinds of smells, my ability to handle spices and mixtures and things of that sort. This was way, way, way up. The ability to smell such things as, well, this was several years ago, but I could tell when I entered the house whether the children had been good or bad. Because I could smell the difference. And 2 or 3 days of drinking chlorinated water wipes that out for at least a month. And it's just astounding. On the other hand, even when drinking chlorinated water, even my wife and I walk into an opening sale of a new place that's just recently been remodeled, we have to turn things like that. Too overwhelming.
Yeah, sorry, I'm talking a lot, but the one thing the paper made me think of also was, and I mentioned that earlier, but in environmental science, often people talk about, use the concept of bioindicators. We say, look at a certain species in some ecosystem, and if it's there, that means that the ecosystem is healthy, and if it's missing, that means it's unhealthy. Lichens disappear when there's too much air pollution. And the article was interesting because it made me think of humans as bioindicators. And that also links to what we were talking about the fact that humans inherently aren't necessarily trusted. So if we say like, oh, are there lichens? No, they're not. The air quality must be bad. You trust that the lichen's not like trying to fool us, but if it's a human who tells us something in my head is making me sick, we think like, oh, that person must be crazy. So maybe that's why when you were reading about the dog animals, you felt that the animal bioindicator is maybe more trustworthy, whereas the human might be so. And maybe anthropologists often think of humans as bioindicators, but engineers.
And maybe I was betraying an insensitivity. I mean, there's a long history of this sort of scholarship in medical anthropology, and maybe the two of you might bring some of that in to the discussion.
Sure. I just wanted to circle back on what you were saying about regulations, and we spend most of our time in the home. I also just wanted to underline that the home is the largest unregulated airspace in America, and it's the airspace that we live in most often. And indoor air spaces are almost always have worse air quality than their corresponding outdoor space. You have the particulate seeping in, you also have the commodities and the construction materials building up. So that's a sort of a profound urgency to these spaces as well. I think it's also interesting that, just to sort of mark a larger trend in governance, is that we tend to govern through information rather than through regulation. So it's governing by saying, hey, this is toxic. I studied these FEMA trailers, which are these highly contested figures of formaldehyde poisoning that were resold across America, and I was tracing them as they're getting resold across the country and percolating through gray markets and being predatorily resold on native nations and things like that. And they were sold with stickers in the window saying not to be used as housing. Bumper stickers that people would just sort of take off. So I think that bumper sticker is sort of a physical manifestation of the ways that we govern through information rather than through law. So I wanted to flag that as well. And in terms of bioindicators and looking to understand chemicals with other species, part of the work that I've been doing is, and I make a gesture to it in the paper, is that common houseplants, low-life plants, do cultivate bacteria in the rhizosphere, the roots, that can metabolize formaldehyde. And so people have been saying, oh, you just need to get a bunch of houseplants and you'll be okay. But the amount of houseplants you'll need is 630 or something to the average home, which is invasive and costly, and will probably increase your humidity levels so you're having a lot of mold. And so at times we get sort of taken by the chemical fetish and move to do things that we romanticize organic toxins, or pretending they're not as bad. And so what I've been doing with Public Lab is we've been using aquarium pumps and reversing the diaphragm, turning them into vacuums, and then moving air through the root system of common indoor houseplants. And we tested one of these kits in a FEMA trailer in Mississippi and found a 40% reduction in formaldehyde with one plant and one $6 hacked aquarium pump. So those are sort of part of the tactics of endurance, is using the ecologies that are already in our homes. We often have these plants. It was a golden pathos, a $3 plant from Home Depot that we're able to use for this. So part of, I have a three-pronged approach to your initial question. One is, how do we know better by making affects and qualitative knowledge count on different registers? And one is, after we assess how bad the infrastructure is, mitigate it in the short term, while using that information, mitigating in the short term with the plants, and then moving towards long-term policy changes, while also the third prong of my approach is working, I guess, more largely for, as opposed to with, this artist named Tomas Saraceno. Anyone familiar with him? Yeah, and there's a project called the Aeroscene, which involves solar balloon travel. This is out there. Involves solar balloon travel as a transportation infrastructure in the future. Collaborations with CNES, the French Space Agency, with atmospheric scientists at MIT that are 3D modeling the air so you can go different directions depending on which altitude you go on. There's no fossil fuels involved, no helium involved, which is helium only comes through natural gas extraction on a commercial level. So that's the third sort of fantastical level. There's like in the trenches work, doing the scientific work, ethnography, and also like a fantastical project of building another transportation infrastructure that may or may not.
Please go into the Sublime.
Yeah. But I don't know if you wanted to talk about the long-standing, you asked a question about sort of the history of anthropology and some of the things that we're doing, or you getting
Actually, can I ask you a question?
Sure.
About this idea of, how you make these effective experiences count on registers that could count on registers of maybe governance. And so, one of the things that I wonder if you worry over is, how are you translating these effective experiences and making them count? And what does like a quantification? So the other day we were talking about the stories and what happens when you start to quantify stories, what gets left out, or what gets rendered silent when you start to focus on the accumulation of numbers in that kind of governmental form that we so rely on today. And I'm thinking so much about Joe Dune's book, Drugs for Life, right now, which is all about how we count illness and how we and how numbers are used to further treatment in a pharmaceutical culture.
Yeah, I mean, we've been working on the project forever, and then we haven't quite gotten to that stage. And I think things will get turned out, and it is going to be difficult. But I think it's reassuring knowing that we're working with communities that, and like with peers like you, that are going to be not letting me get seduced by certain informational practices while creating others. And I think that's also what we've been trying to do with this online platform that we've been building for a long time, that we've sort of run out of money to build. and trying to get beyond the narrative versus data debate while creating sort of a link between the two. How can you not have to choose necessarily, but you can give different kinds of data to different people that need different kinds of narratives to make their decisions.
Are you finding that there's certain kinds of data that count more? So I'm really interested in time. Like, what is, for the time of illness, for example, how many such illness events do you need to have over how many years at certain times of day, or certain months of the year are worse than others? So I'm really interested in temporal registers, for example, and how is that one that you found is particularly useful? Because I think that has like a scientific legacy,
Yeah, no, I think it's really important for what I do. We haven't made that next step. I can't really speak to that. But I was proposing to Allie on the phone yesterday that we would employ some of our students because we're interested in not just like creating new devices. Oh, you want to test something? We need to build something new. But, the state isn't doing its job. Let's intervene. But we want to survey the different state departments of health to see what kind of information different state departments of health need in order for them to do the actual testing. So how can we better equip people to know what stories to tell their state government so that they can get the testing done from them, rather than having like a civic response necessarily, building more stuff there at the moment. So I was hoping that your students would help us do that. So I'm glad.
Later on.
So I've got one final question for Nick, but before I ask it, are there other folks that want to jump in? And maybe I'll ask my question, and as I ask it, we can pause and see if you have the question at that point. But it was basically just sort of a panning out question, asking you to sort of try to point us in the direction of where the chemical turn of anthropology is headed. We've talked about some of the places it's been. Other folks besides Joe Dumet that haven't come up are people like Kim Fortune or Corey Hayden, who've been working on chemical issues. So I was wondering if you could just sort of depart from the conversations that we were having in Philadelphia with people like Beth Povinelli and Tim Choi, to sort of point us towards where the discipline's headed with chemoethnography, if we want to call it that. But are there other questions here? Yeah.
I don't know if anybody can comment on it, but so typically you want to estimate people's exposure to certain chemicals that are persistent and that they can't necessarily detect. One way of doing it would be to get a blood sample. They still find DET in people's blood for years after that. The one issue that they have is that they don't know necessarily what the structure of the chemical is that they're looking for. So they can look for known chemicals, they can't look unknown chemicals. So I think recently they found, for example, that firefighters had some elevated concentrations of chlorinated organic, what they think is being used as an additive in firefighting equipment. But they had a hard time proving that the firefighters were had it in their blood because they didn't know exactly what. So how do you get around that if you're trying to, not knowing what you first need to know what the chemical concern is. But I guess that relates to, you can't test for something if you don't know what you're testing for.
And also this question of speciation, and like if something like formaldehyde is changing so quickly, what is it changing into, and what are the what are the toxic liabilities of those metabolites or whatever?
That also relates to the shale, because when people talk about concerns from fracking, they're not just talking about a single chemical, but some people are concerned about radioactive bronzium, and other people are saying, oh no, just use other things. So you need to know what you're looking for.
So here's a piggyback question. You and Nick, your article by suggesting that it can actually be difficult to network from below to try to affect some kind of change because of the social precariousness of a lot of the people who are affected. And in relation to the sort of question of the chemicals involved in fracking, I attended a workshop discussion earlier this week where so many of the formulations are proprietary. So is it possible that that there is an effort from above, and again it would require kind of regulatory intervention, but in which companies that introduce chemicals into firefighting foam or into fracking compounds actually must disclose, even at that basic level, disclose what goes into those in order to introduce them into a public is a tricky word here, into an environment, into a human or multi-species environment.
I think, well, I mean, part of the issue is that the general public doesn't realize necessarily. Normal people might think like, oh yeah, chemists, analytical chemists can examine the chemistry of some solution and determine what's in it. But that's actually really, really hard to do if you don't know what you're looking for, which is what people get like Nobel Prizes for discovering the structure of some molecule. If people realized how hard it is to detect something you don't know what it is, maybe they would demand that people release the chemical structure of the compounds for you.
And there's also a question of what's going in versus what comes out. There's also drawing a lot of stuff.
It's my understanding that the composition of the things is scientific.
Yeah, I think the reports some stuff on the government website now.
There's a site where there are companies who have volunteered to disclose. I don't know if they're required.
In that serial discussion, right, after Davis, I would imagine.
Yeah, it suggested that there isn't any requirement for reporting. And in fact, that's where the science is working to try to figure out what's the right composition for the fluid to get the maximum out of the shale. So that's what they're actually constantly tweaking and experimenting.
Without sort of any sort of toxicology.
No, I think most of it is in the outcome. Does it increase the percentage of gas released from the particular shale? Then all right, so that's better. Can we get it a little better?
One of the problems is actually the increase. It depends on where the water that the solution comes from.
This is kind of a little bit more speculation. It's a question as to how much you, drawing from what we've been talking about in terms of the kind of the search for domestic solutions and the body as a bioindicator, how much potential there is for a kind of internal and individual solution to this, and whether that kind of almost a cyborg kind of situation in which, without larger infrastructural change or fiscal responsibility or any of these other things that might stop it entering our environments, whether there is any, what kind of the scope, or whether you think that there's any, it's kind of not quite formulated in my head, so it's hard to articulate, but in terms of the physical bodily experience of it, whether that also will become the site of solution and detoxification, and whether you mentioned taking blood tests and this kind of idea of maybe the individual responsibility would be the only way in which we're then able to fully both monitor and cleanse ourselves of these situations without larger societal shifts, which probably aren't happening anytime soon. And whether, I don't know whether there's anything within your research, Nick, that's indicated that people would be, that when you mentioned the plant and channeling the air through the soil of the plant, it kind of is that domestic solution. And then I think your cups as well kind of made me think of that these kind of seek in order to adjust themselves in response to the environment, and how much as we adjust. It also, the conversation today with Nick, just I have this thing going around in my head in terms of that the difference between a medicine and a poison is dose. And these are naturally occurring chemicals that we produce ourselves, but the difference here is the dose. And so therefore, whether that kind of internal control of what we're intaking as the dose might be the only point of kind of autonomous solution that we have control of
So gives you the final word, Nick.
Final word, just one. Yeah, I think what's really interesting also about this chemical is that formaldehyde, the concept of the pharmacon, like that's something that's both a poison and a panacea, something that is curative at one level, medicine, and poison at another. It gets sort of complicated because we have formaldehyde in our bodies naturally. It is, I didn't mention in the article, but what I don't mention also in the article is that there's no like pure equilibrium of formaldehyde that we're going to find. The amount of formaldehyde that we have in our brains right now is also the same, is at a level that in labs they demonstrate to that level of formaldehyde can degrade neurological cells in labs. So what we already have is not necessarily healthy. So physiology and pathophysiology are not as easily parsable when you look at this chemical all the way down into the human body. So yeah, and it's interesting, like in terms of biomonitoring, it's really hard because it gets metabolized so fast. Within minutes, inhaled formaldehyde is out of your blood. And in the process, they also catabolize an enzyme that's important for bronchial dilation. So it's what it destroys in the process of being destroyed in the body that is interesting. Even though it's not there, what was taken by it not being there is harmful. So the individual is really important, and I think that's, I have these individual responsibilities to all these people that I've talked to over the last few years, and that's where taking this NASA research, which is the plant science, and sort of giving it a little bit of a hacked twist and a cybernetic enhancement is an important part of this project for me. But it's also not just me, but we at Public Labs, when collaborating on this project, are really excited about it. It's also you're helping people endure their exposures, but you're also helping systems of exposure endure themselves. So you enable the continuance of a certain scale of exposure and a certain infrastructure of exposure by mitigating. So that's why, on its own, the individual approach isn't necessarily something that makes me sleep well at night. And then I also wanted to sort of move quickly through the gestures about fracking. What's interesting is everyone focuses on the fracking process itself and the water and the drilling, and when you go to places of intense natural gas extraction, it's really the air. Also, may expose my biases as I'm an airhead and I'm interested in folks in the air, but the air quality is profoundly affected. The emissions from the compressor stations that are burning gas from far away. At one point, a group I was working with found higher levels of ultrafine particulate matter than was found in coal mines, confined spaces. This is very close to the compressor station. But emissions things being burnt, diesel trucks moving throughout the night, and a huge proliferation of small-scale refineries, basically, these compressor stations. So we were worried about the water, and the water is a concern, but it's also what we're doing to the air in a natural way. Nothing is just part of the permanent emissions of all of these things, and permanent venting, and non-punitive venting, and things like that. And so in the community I was working with in Northeast Pennsylvania, they moved from trying to unite through the water to trying to unite through the air. So this brings me to Eben's question about where we're going with chemoethnography. And so one of the things that I'm trying to do in this piece, and also thinking with people like Tim Choi and Beth Pavanelli, is how can we develop a critical vocabulary for us to deal with ecological challenges that we're learning actually from the atmosphere. So sublime is not just a concept of philosophy, but it's also a chemical term, and it's a process of moving from solid to gas. And so this process of sublimation is a material practice, and it's also an epistemological practice. So how do we think with the air to develop the critical language? We need to address some of these pressing environmental issues that are of this massive scale that is sort of unfathomable.
So thank you, Nick. Thank you to everyone. So I'd like to invite you to opening receptions.